Hello everybody, Math Hobo here, and today we will be talking about the integrals of the product of sines and cosines. So we will write out the definite integral here from 0 to 2 pi of sine nx times cosine mx dx, where n and m are both in the set of integers, denoted by boldface C. So we will try to evaluate this integral here, and we will see that it equals a very special number. And this expression right here, sine nx times cosine mx, that looks very familiar to us because we discussed the product to sum expansions in a very recent video. So this expression, when integrated from 0 to 2 pi, equals the integral from 0 to 2 pi of half multiplied by sine m plus n x plus sine m minus n x there should be another bracket there, dx. So we basically use the product to sum formulas, which says that sine A cosine B is equal to half multiplied by sine A plus B plus the sine of A minus B, and the half includes everything within the brackets. So then we can rewrite this by splitting by first taking out half from the integral by factoring it out, and then by splitting this sum into two integrals. So what we get then is integral 0 to 2 pi half times integral 0 to 2 pi of sine m plus n into x dx plus half, I'll just erase the dx, times integral 0 to 2 pi of sine m minus n x dx. Yes, so very well. I can erase this now. I'll rewrite the 0. Okay, so now we have two separate integrals, which are very easily evaluated because m and n are both integers, as we remember defining them to be. So m plus n must also be an integer. So then the sine of an integer times x, integrated from 0 to 2 pi, is always going to equal 0. So this entire expression evaluates to 0, and you can check this by watching the Math Hobo video on the integral of sines and cosines, and it definitely checks out. But then we arrive at an interesting conclusion. This m minus n must also be an integer, so the sine of an integer times x again is equal to 0. So voila, this entire expression equals 0. And that concludes our first video on the integrals of products of sines and cosines. Thank you very much.